Hi listeners, Benjamin here. It is Wednesday evening, just before midnight here in the UK, and I stayed up much later than I would usually to watch the launch of NASA's Artemis II mission, which blasted off about 21 minutes and 55 seconds ago from Kennedy Space Center in the US. Now, this mission will take a crew of 4 around the moon and back, and there'll be a lot of science being done along the way. Joining me to talk about all of that is Alex Whitsey, who covers all things Space for Nature and who joins me from Colorado. Alex, hi.
Hi, good evening, good night, good morning, wherever you are.
Well, we have been watching the launch together and say we're just into the mission. It was a very tense time. For listeners who maybe were asleep at the time, where are we right now with the mission? What's going on?
What's happened is we've lifted off and the astronauts are on their way to going into Earth orbit. The plan is that they're going to stay in orbit around the Earth for about another 24 hours or so. They're not quite there yet at the time that we're speaking, but hopefully by the time this comes out, the astronauts will be going around the Earth, kind of checking out all their systems to make sure they can go on their way to the moon after that.
And as I say, it was quite a tense watch for all of us, and it's been quite a journey getting to this point, right? I've been glued to weather reports, not just here on Earth, but of course, weather reports from the sun as well over the past 24 hours. But the launch itself was a bit of a sprint finish. They had a 2-hour window and they hit it right at the start.
It turned out to be a really pretty flawless launch. I mean, all things considered. So this is really important because this is a big new rocket that's flown only once before. It's never flown with humans on it. So there's 4 souls on top of that giant flaming streak that's lifting up into the sky. So a lot is at risk here and at play here for NASA. But when push came to shove, the preparations went smoothly. The rocket had been bedeviled by leaks in its hydrogen and helium propellant lines and other sort of like liquid fuel problems, and none of those happened today. So in the rundown to the final launch, actually things went remarkably smoothly.
And obviously the astronauts on board, they're still strapped in at the moment, but they are going to be doing a lot science-wise, despite this really being essentially a round trip, not least testing out the Orion capsule that they are ensconced in for the duration of their mission.
Yeah, so this is going to be a nearly 10-day mission, and every single minute is jam-packed. The goal of the mission, of course, is to make sure that the spacecraft they're in, this thing called the Orion capsule, can in fact support humans traveling into deep space. Now, just as a reminder, since the last Apollo astronauts came back in 1972, all the astronauts we've had since then have been in Earth orbit. They go around on the various space stations that are in low Earth orbit. We have not had anyone in deep space. So there's all sorts of experiments and all sorts of stuff that's getting tested on this flight. Some of that is science. Now, of course, the main goal is to make sure the spacecraft can work and keep everybody alive for those 10 days. But there's research being done kind of along the way.
Yeah, and of course, you and I have been following Artemis since it began, really. I remember sitting watching Artemis I launch with you as well. And one of the things we talked about then was radiation. A lot of the sort of research aspect of this trip is looking at the effects, potential or otherwise, of radiation on humans as they go into deep space.
Yeah, because again, we have many decades of understanding what happens to the human body and microgravity or zero gravity going around in space stations. But when you leave Earth's protective magnetic shield, you're suddenly exposed to much more fluxes of radiation, energetic particles that can hit the body, can cause damage, and so on and so forth. So a number of the studies that are going on this Artemis II flight that is already underway. Gosh, it's hard to say that, isn't it? It's been in the future for so long. They're actually in flight now. Yeah, so a lot have to do with the effects of radiation on the body. They're doing this cool personalized health thing. They call them organs on a chip. They're not really organs. They've taken these bone marrow cells from each of the 4 astronauts and put them on these little chips that look kind of like a little USB port or whatever. 1 chip per astronaut traveling into space. And then a matched chip is staying back down on Earth. And so when they come back after those 10 days, they're going to look for all these different genetic and other changes in these cells and see kind of what has happened to these matched chips that flew in space.
And of course, one of the big things happening is that these astronauts will travel a huge distance away from Earth, the furthest that humans have been, and they'll be seeing the far side of the moon with human eyes. Now, of course, they're not the first people to have seen that. The Apollo missions, as you say, happened half a century ago and many times went round the moon. And there are orbiting spacecraft as well. But actually physically seeing this with the naked eye, this area of the moon is important.
It actually took me a while to buy into this argument that human eyes could see a lot more, and that would be seeing sort of more and new and different things than we have with the many orbiting spacecraft from many nations. But I think I've been talked into it now. When you look at the moon with the human eye and the human brain, the perception is very different. So a lot of the things that the Artemis II crew will be looking at as they fly around the far side of the moon is changes, things that don't get picked up in a static camera image, things that our brain needs to process. So like one of the examples that's trotted out is that Harrison Schmitt, who was a Apollo 17 astronaut and a geologist, the only scientist to walk on the moon, sort of very famously spotted this orange soil, this orange tint to some deposits. And that turned out to be an interesting discovery because his eye could pick up these color differences. Now, of course, orbiting cameras have like all these cool like multispectral analyses or whatever, but sometimes you just got to look at the whole moon all at a time, and you might be able to spot, differences between this basin and that basin. There's also a lot of talk about light changes on the moon very dramatically. The sunlight falls across these craters in the terminator, which is like the limb of the moon. And so the changing shadows and the changing sunlight reflecting off that topography, people have sort of made discoveries based on that.
And presumably by being further away than the Apollo astronauts flew, there'll be a wider field of view as well. So this mission will be able to see more of the moon?
Yeah, so the Artemis II astronauts will see the full disk of the moon. The analogy is if you had a basketball and you held it out at arm's length, that's kind of what you would see. So in one respect, they'll be looking out the windows and there's like a giant disk of the moon, but it's like at arm's length. The Apollo footage, if you look at it, is super cool because they're like something like 60 to 100 kilometers above the lunar surface. And so they're moving very closely and it's very dramatic, this horizon and these craters. In fact, the Apollo astronauts were so close, they couldn't see things like the North and South polar regions because they were beyond their horizon at that time. So the Artemis II folks looking at it again from that basketball at arm's length will be able to see more of the whole thing.
And I think you intimated there are long-term aims for this as well. Obviously, this is a feat of engineering and science and all the rest of these things put together, but essentially it is a stepping stone to eventually landing on the moon. And of course, that was done in the 60s and early 70s. So how is this different?
Well, it depends on who you ask. But I talked to a lunar scientist yesterday who made the argument that this is different because there is a longer term plan. So the point of Apollo was to land a human on the moon from the US before the Soviets did. And there wasn't really clear what was going to happen after that. In the early 70s, the Apollo program got wound down. There was some space station work. Eventually, NASA pivoted to reusable space planes in the form of the space shuttle and the space station in Earth orbit as a destination to get to. The argument this scientist made to me yesterday is that NASA has a plan for a longer term return to the lunar surface to build a moon base. There's all this talk about many, many robots going down to the surface, many more human missions. We are a really, really long way from any of that happening. But I will say that in my decades of covering the space program, where there have been many starts and stops on the way to establishing a program that could get astronauts to the moon, might get astronauts to Mars, this is definitely the longest and most developed steps towards that. And so the difference today, one might argue, is that we're farther along than we ever were. We have humans going into deep space for the first time in half a century.
And of course, we've been talking in somewhat abstract terms, but there are 4 people who are currently on this mission. Tell me about them and their backgrounds.
All astronauts are kind of superhuman achievers and like everything that they do. And that's exactly what we have here. And there's a number of notable firsts on this mission. With pilot Vic Glover, we have the first person of color to go beyond low Earth orbit. With mission specialist Christina Cook, we have the first woman to go beyond low Earth orbit. With Canadian astronaut Jeremy Hansen, we have the first non-American to go beyond low Earth orbit. All the Apollo astronauts were American white men. So we have a significantly more representative and diverse collection of humans than we had before. Their commander, Reed Wiseman, is an American. So these are the 4 humans that are on it together. They've been living and working and training together for a very long time. They're a very tightly bonded crew. You kind of have to be. These are 4 people living in a tiny camper van for 10 days. It's going to get a little stinky in there. You got to get along, right? But they are a highly accomplished crew, even by the incredible standards of astronauts, I would say. So fascinating people, really.
And listeners will get a sense of how excited we are about this endeavour. But of course, the world is a febrile place right now, Alex, and there's a lot of folk who maybe aren't convinced about this mission. I mean, there seems to be a creeping sense of almost Artemis indifference, or at least there was until the mission happened. Obviously, things about cost come up, but a bunch of other stuff too. What have folks said to you about that?
I'm really curious to see kind of how this develops in terms of public perception. In the 60s, the Apollo program, at least in the US, was very unpopular among the American public. People didn't see the point in spending so much money. I mean, ultimately, it was more than $250 billion in inflation-adjusted dollars for the Apollo program. And especially in the tumultuous 1960s, a lot of the American public didn't think that the government should be spending all that money to send people to the moon when there were so many social issues here on Earth. And like today, we've got wars, we have the climate crisis, we have so many pressing things that need our attention here. So I am really curious to see how this picks up in the public imagination, whether people see the Artemis II flight as a globally unifying thing, or if they see it as a US partisan thing. So we'll see how the globe receives this mission and what it means.
And I know we keep talking about Apollo, but it's hard to avoid the parallels. And the photographs taken on these missions, you think about Michael Collins' picture, where everyone who's ever lived apart from him was in this picture. Are we hoping for something similar from the Artemis II mission, this kind of wonderful encapsulation of what's going on?
I think we're going to get something similar, but maybe also a little bit different. So very much the Artemis II flight is analogous to, in 1968, the Apollo 8 flight. That was the first Apollo flight to go around the moon. That was 3 people. They orbited and then came back. But very similar in many ways to what Artemis II is doing. And that is when that first famous Earthrise picture was taken, when the astronauts were going about doing many other things, and out of the corner of their eye, they caught the picture of Earth rising above the horizon of the moon, which was striking and beautiful. And people had not thought about that, this beautiful pale blue dot. And they are expecting Earthrise and Earthset images like that as well on Artemis II flight, just because of the geometry of how it's flying around the moon. And so we're going to expect images like that. And I'm really curious to see how or if those images grab popular attention. In the late 60s and early 70s, those Earthrise images became symbols of the early environmental movement. So I talked to a historian of Earthrise this morning, and he was saying that he was curious with today's kind of ultra connectivity, absolute gratification, selfies at all time, AI visualizations of things left and right. Is fresh imagery of Earth from space going to really tug at people or connect with people in a way that it did in the 60s? Will it do the same again? Really, really curious to see where that goes.
And obviously only time will tell what happens. But bringing it back to the mission as it's going on, what should folk be looking out for right now? What are some of the milestones and the times and what have you?
So at the time we're talking now, again, we're sort of entering Earth orbit where it will be for about 24 hours after launch. This is assuming things go correctly. Then they will do the translunar injection, the TLI, the engine burn that sets them on course to the moon. And then it will be a little quiet for about 3 days as they coast to the moon. They'll be very busy doing experiments and exercising and figuring out the space toilet and all that stuff. And then everything's going to pick up and get very exciting as they slingshot around that far side. So that will be, sort of 4 or 5 days into the mission. They call it flight day 6, but it's really more like 5 days after launch. And then it will be sort of a quiet 3 days coming back from our perspective. And then a lot of excitement, a lot of attention when they return. There are sort of questions about, will the heat shield on the capsule hold up? Will the parachutes deploy? Can they safely splash down? That's kind of the trajectory of the mission.
And we will, of course, be covering it here at Nature. And Alex, you personally, you've been covering space missions, as you say, for a very long time. Is it possible to rate this one? Where does it stack up? What are your thoughts? What are you feeling right now?
I never thought in my career that I would cover a moon mission with humans, right? So, I've covered spacecraft that have flown around the solar system, spacecraft that have gone to the moon. I've talked to astronauts and covered astronauts who've been to the space station, who've flown on shuttles, all that kind of stuff. But to me, this is a career highlight. I really never thought I would be covering a mission where humans go back to the moon, and I am. And it's really an extraordinary place to be.
Well, that's a wonderful note to leave it on. Alex, we'll put links to all of your stories in the show notes of the podcast, and hopefully you'll come on again soon to tell us how it's been going on. But for the time being, Alex Woodsey, thank you so much for being here.
Thank you, and get some sleep, please.
Will do.